Hello, boys and girls. Today I'm going to be going through section 1.1 of your Reveal textbook. We're going to be learning about exponents. Our I can statement for today is I can use integer exponents to show repeated multiplication of rational numbers. I'll try to go through this quickly since you all sat through it in class. These are our vocabulary terms for the week: base, evaluate, exponent, order of operations, and power. When we're looking at a power, this is known as a power. It's the base and the exponent together is called a power, right? Order of operations is PEMDAS. You all remember that. And evaluate means to find the value of an expression. Tell me what it's equal to. If I asked you to evaluate this power, you would tell me 25 because it's equal to 5 times 5. On the next page, you're going to be learning to write products as powers. It's important that you know the term factor. Okay, factors are numbers that are multiplied together. So here we have 3 being written as a factor 4 times. Because there are 4 of them, the exponent on the 3 is a 4. Also, during this presentation, the page number of your workbook will always be here right underneath the word class flow. So you'll know where to turn in your workbook to see this example. Now we're on page 4. Here they want to show you that you can have 2 different bases in an expression. So we can have a base of 2 and a base of -4. There are 4 2's, so the exponent is a 4. And there are 3 -4's, so the exponent is a 3. Right down here they want to see that you understand what the names are. If you look carefully, and I'm sorry for the resolution on this, these are not good. This little bracket here is telling you that this box means the whole thing. Okay, well, the whole thing is called a power. Now, I'm writing on a digital tablet thingy, so please excuse my handwriting. Pointing at the little tiny number to the top right-hand corner, that is our exponent. I write much better on the Promethean board. And the 5 is the base. Okay. Down here, they're showing you 3 to the first power equals 3, so you would say 3 to the first power. Okay. The next one shows you 3 to the second power, which can be said second power. It can also be said squared. Second power and third power also have these alternate words we can use. 3 to the third power can be 3 to the third power. Help if I could spell. Or cubed. Third power can also be, you can also say it cubed. This one has 3 to the fourth power. And then they want to make the point that you can say 3 to the power of 4. If anybody wants to sound bougie, you could do that. Okay. And then down here they're saying 3 to the nth power, or 3 to the power of n. Next page. Here, this is example 1. It's on page 5 in your workbook. They're showing you that you have -2 times -2 times -2. So the base, -2, is used as a factor 3 times. And the base 3/4, 1, 2, 3, 4, is used as a factor 4 times. So the exponents are 3 and 4. And you can see here they've got a 3 and a 4. So for the check, which of the following is equivalent to the expression? Well, there are 1, 2, 3, 4 2/3. So right away, we know it's got to be either B or C. Those are the only ones that have a 4 on the 2/3. But let's count the 5's. -5, 1, 2, 3, 4, 5 of those. So that would mean that C is the correct answer because -5 to the 5th power. Writing algebraic products as powers. So now instead of numbers, we're going to use letters. Same rules, same principles, just using letters instead. So in the example here, what they have done is they have taken these letters and they're all mixed up. So they've rearranged them so that the A's are together and the B's are together. And in math, we always do this alphabetically. So you would always put A before B. So A times B times B times A times B is equal to A to the second, B to the third. I didn't put the dot in there. You don't have to have the dot when you're multiplying variables. Okay. Write the expression a times, I'm not going to read that whole thing, using exponents. Well, count how many a's there are. Let's see, there's 1, 2, 3, 4, 5 a's. So it's either going to be C or B. And how many b's are there? 1, 2, 3. So that means in this case, B is the correct answer because it has a 3 on the B. Next, when we have negative bases, like down here how we have a -3, it matters if the negative base is in parentheses or out of parentheses. If the negative base is in parentheses, then the exponent acts on everything in the parenthesis, which means the negative and the 3. So this would be -3 times -3 times -3 times -3, which would be a positive value because when you're multiplying 4 negatives together, your answer is going to be positive. And this is going to be positive 81. But over here, because the -3 is not in parentheses, the 4 only acts on the thing it touches. So the 4 is only going to make the 3 appear 4 times, not the negative. So 3 times 3 times 3 times 3 is still 81. But in this case, this one little stray negative out here gives us -81. There's a big difference between positive 81 and negative 81. If you don't believe me, try having negative $81 in your savings account. Not much of a savings account. No. Okay, so evaluate powers. We're going to be using the order of operations. You remember order of operations is PEMDAS. Okay, PEMDAS is parentheses and grouping symbols. E is for exponents. M and D are for multiplication and division. Because M comes first does not mean M gets done first. These are done from left to right. So if there's a division before a multiplication, you would do the division first. Same with addition and subtraction. They're equal, so we do them from left to right. I'm sure this isn't the first time that you've heard this. I know that you've learned this before. I'm just reviewing that. Okay. Example number 3, evaluate numerical expressions, right? So they want you to, let's see, they've given us -2 to the 3rd power. The -2 is in the parentheses. Okay, so this is -2 times -2 times -2. Now, because there are 3 negatives, this will still be negative, all right? If there had been 4, it would have been positive. But because there is an odd number, this number here is still going to be negative. So -2 times -2 times -2 is -8. Okay, write it in that little box there. And 3.5 times 3.5 is... I don't know that. Let me get a calculator. All right, 3.5 times 3.5. 12.25. I didn't have my answer key here. Thought I was just going to wing this. All right, and -8 plus 12.25 is 4.25. I didn't do that in my head. I cheated and looked down here. I saw that. Okay, so they want us to do the check here. Well, 8 to the 3rd power, that's 8 times 8 times 8. You can use a calculator. I can do 8 times 8 is 64, but I can't do 64 times 8 in my head. That is 512. And -3 to the 3rd power is going to be -27. All right, so 512 minus 27 is 485. Moving along, example 4, evaluate algebraic expressions. Okay, here they're telling you to replace A with 3 and B with 1/2. Okay, so they've got A squared plus B to the 4th is the same as 3 squared plus 1/2 to the 4th. Okay, so then they do 3 times 3 is 9. All right, so we'll put 9 here. And 1/2 times 1/2 times 1/2 times 1/2. Well, 1/2 times 1/2 is 1/4. And then another 1/2 times 1/2 is another 4th. And 1/4 times 1/4 is 1/16. Okay. And so then you add them together, you're going to get 8 and 15/16. Oh no, that's positive, my mistake. You're going to get 9 and 1/16. I was subtracting. All right, now down here in the check, we have a to the fourth plus b to the second. They want you to put in -3 for a and 6 for b. So here's what this is going to look like. You're going to put -3 in parentheses because you're substituting. Always use parentheses when you're substituting. And then it's plus b to the sixth. I don't need parentheses on the 6 because it's positive. This is -3 times -3 times -3 times -3, which is positive 81. And 6 to the second power is 36. So when you add those two together, you're going to get 117. Gosh, I hope that's right. I did it in my head and it's early. I'm sure you'll let me know if it's not. Okay. Evaluate algebraic expressions is example 5 on page 8. All right. Again, they've given us variables and they're asking us to substitute these numbers in for C and D. Okay. Let's see. It's D to the third, and we want to substitute 2/5 for D. So they put 2/5 in where the D was, and they put -4 in where the C was. And this -2 was part of the problem to begin with. It just gets to stick around. So we have 2/5 to the third power here, but we need to use our order of operations and solve what's in these parentheses. Within the parentheses, the order of operations still holds. So we would do exponents before we would do subtraction. -4 to the second power is 16, and 16 minus 2 is 14. Okay. So this is -4 times -4, which gives us positive 16 minus 2 is positive 14. Now, 2/5 to the third, that's the same as 2/5 times 2/5 times 2/5. I think I'll get better at this writing board. 2 times 2 times 2 is 8. 5 times 5 is 25. Times 5 again is 125. Okay? And you can see they've already got the answer over here for you. It's 14 and 8 over 125. Yes, get used to it. 8th grade math problems don't always have pretty answers. Okay. Down here in our check, they've again got you substituting fractions and a whole number. So x is -1/3. So we put -1/3 in parentheses to the second power plus substitute 5 for y minus 85. Okay. Well, -1/3 to the second power is positive 1/9. And in the parentheses, do the exponent first. 5 to the third power is 125. And 125 minus 85, let's see if I can do that in my head. 125 minus 85 would be 40. Okay, and so then we would have 40 and 1/9 as the answer here. It's 40, right? Yeah, I think it's 40. Okay. All right, moving on. All right, this is an application problem. They're asking you to compare two numbers written in scientific notation. They're saying the table shows the average weights of 2 endangered mammals. How much more does the brown bear weigh than the panther? Well, the panther weighs 2 to the third times 3 times 5, and the brown bear weighs 2 times 5 to the second times 7. So they want to know how much more does the one weigh than the other one. Just figure out, evaluate what these are equal to. 2 to the third power is 8. So this would be the same as 8 times 3 times 5. Okay. Let's see, what would be the easiest way to do this? Let's do 8 times 5 is 40. And 40 times 3 is 120. So the average weight of a panther is 120. For the brown bear, let's do the exponent first. 5 to the second power is 25. Okay. 2 times 25 is 50, and 50 times 7 is 350. So a brown bear is quite a bit bigger than a panther. Then your final step would be to take the weight of the brown bear and subtract the weight of the panther, And that will give you the difference in weights, a whopping 230 pounds. Okay. This is the check for that example. Interstate 90. I thought this was interesting because we have Interstate 70 goes right through Dayton here. Interstate 90, which I'm not familiar with, is this long, 2 to the 4th times 7 to the 2nd times 4. Interstate 70 is this long. How much longer is Interstate 90 than Interstate 70? So I went and found you these maps so you can kind of have a look. 90 goes all the way from the East Coast all the way out to, what is that, Utah? And, or is that 70? That's 70. So it goes from the East Coast all the way to about Utah. 90 goes one end to the other. Check that out. I've never traveled 90. Maybe I'd put that on my bucket list, huh? How much longer is 90 is the question, okay? So you would go up here and you would figure out what 2 to the 4th is, what 7 to the 2nd is, and what 4 times 4. Use your calculator, okay? Here, I can get you started. Let's see, 2 to the 4th is 2 times 2 times 2 times 2, so that's 16. 7 to the 2nd power is 49 times 4. I can't do that in my head, but you can do that in your calculator. The second one, 2 to the 3rd power is 8. 5 to the 2nd power is 25 times 11. Do that in your calculator. How much longer is this one than this one? That's the only thing they're asking you to do in this problem. Finally, your assignment. This is page 11 and page 12. I want you to do both pages for your assignment. This is your Thursday assignment. You would do both of these pages, and then Friday when you report to class, we can't trade and grade, so you'll have to grade your own paper. And then these problems will be similar to the problems that you will find on your quiz on Friday. All right? That's all I have for this section. I hope that was helpful, and feel free to watch this more than once if you really enjoy watching math doing. It would be great. Until then, I'll see you in section 1-2.